Hello, good afternoon, and happy birthday to us. It's the first birthday of our Sunday Science Q&A. We started exactly 1 year ago, and lockdown has continued for so long. And also, we just decided we keep doing it, whatever happens as well. So I think we will continue to do this, hopefully when we are all freer than we have been before. And I hope you've enjoyed the episodes you've seen so far. We have a fantastic show today. We're joined by Nicole Stott. Some of you will have heard, I hope, her Tips for Existence, which was the second episode that we put out after the episode with Brian Greene. And today, if you have any questions, they can be questions about space exploration, they can be questions about engineering. Helen, of course, is with us as well, so that any kind of shortfall that we find, Helen will be able to fill in that. That does, of course, mean as in fact, last week we didn't have any questions about whale poo, which was somewhat anomalous. Yeah, if you have got the questions about bubbles and whale poo and all the normal things, but also broadly across the world of physics and pretty much everything else, some way or other we'll find a way of covering it. And you can email those questions, or you can just pop them in the in fact, the best thing is to put them in the live chat, or to tweet us at Cosmic Shambles. I mentioned Tips for Existence. The latest episode, the one that's going to go up on Wednesday, is with Carlo Rovelli, whose new book Helgoland is fantastic. It's one of those books about quantum mechanics where every now and again I imagined I understood something. I mean, that disappeared eventually, but I did imagine for a moment that I understood something. So that was a delight. And he is a wonderful writer, and also just very interesting, the different kind of worlds that he has been into, and, you know, going through the phase of sitting in a bandana listening to Allen Ginsberg, doing all those other things as well. So he has a very broad view of trying to understand and gain some kind of meaning of what it is to be a human in the universe. Also mentioned that our latest episode of An Uncanny Hour has gone up, and that is all about Derek Jarman and the film Jubilee. And for that, we're joined by Richard O'Brien and Toya Wilcox and John Savage and John Robb and Kosi Fanny Tutti, and that is all available. All that stuff's available at cosmicshambles.com. And on Tuesday morning, we're going to do, because it's also the anniversary of our first ever stay-at-home festival show that we did. So Josie Long, myself, and Grace Petrie will do a live show on Tuesday morning, 10 a.m. GMT. I think that's pretty much everything covered for the time being. So let's start off with Helen. Helen, now we were talking about this episode, and we were talking about engineering. And so you have something. Now, this is exciting for us because neither Nicole or I are going to be able to actually see the footage you're about to show, but we will then discuss it, the minutiae of every detail, as if we were a newspaper journalist, as usual, making stuff up and imagining that we'd been there. Is that okay?
Well, we'll give you marks out of 10 afterwards, but it is the sort of thing you'll both have seen. So just to explain to the audience what I'm about to show. So Trent is going to put up a still of what you can see, and this is a ship on a ramp. This is the RRS, the Royal Research Ship Sir David Attenborough, otherwise known to the world as Boaty McBoatface. So this is the UK's newest research ship. It is just about to enter sea trials. It's not quite there yet, but it was finished. The way ships are built the whole engineering of a ship is impressive. So this was at Camel Laird in Liverpool. The ship is built in a massive, like the biggest shed you've ever seen. And it's welded together bit by bit over, almost a year. And then the day comes where they have to push it out of the shed and actually get it onto the water. So the top of the ship isn't finished, but what's everything below the waterline is. So what you can see here is this massive ship. It's 120 meters long, this huge research ship, and it's on a slope at Camel Laird, this shipyard. And on the other side of the ship are the 3,000 people who built it. There's this really strong thing in Liverpool about the people who make this technology work. So that 3,000 of them are on the other side. All the posh people are up the back of the ship. And I'm on the side where you can see. And so what you're going to see is the moment the ship launched. Now, just some a little bit more you need to know for watching the video is that there is nothing holding. This ship is on a slope, pointed down towards the water. There is nothing holding it in place apart from two small chocks, and you can see there's some blokes hanging around near the bottom of the front of the ship. They are going to move this tiny bit of metal that is holding this gigantic ship in place, and there is nothing moving it apart from gravity. It's sitting on a layer of grease. And so what we're going to do is we're going to play the video, and what you're going to see is the guys move the chocks away, and then you'll see what happens when a massive ship goes into the water. So Trent is I'm going to give you that countdown, Trent. So please start the video in 3, 2, 1 now. And so you can hear the guy in the background about to do the countdown. So here's the countdown.
3, 2, 1, launch.
So he says launch and nothing happens, but you see that guy just run out to the side. He's just moved the massive metal. Now wait for this. And then it moves. And every time I see this, it makes me cry. And you can see it's accelerating as it goes. And then this gigantic thing is moving so quickly. And then that's it, it's in the water. And you can see the tugboats on the other side are going to move around to it. To actually get hold of it, because there was nothing holding that ship in place. And the thing that gets me about that video, and I'm sure everyone else, I was there, so it's a bit different for me, is that it's so free. It's this massive object which is so free. There is nothing holding it, and gravity just, and you can sort of tell how big it is by that pause. Anyway, so I wanted to share that, because I don't think many people have really seen that video like that, because when they show, all the press of it, they just go, oh, a big ship went in the water, and they all focus on the splash. And actually the thing that really showed the scale was just that pause. So yeah, that's what I want to show everyone.
Now, you see, I've known you for a while, and I've never seen you tear up at a moment of kind of, great human achievement. So obviously that's not the only one. So are there certain things, certain levels of magnitude or levels of ingenuity where your attachment to it, you just can't help it? Because I think it's a very beautiful thing to see that, human achievement and all those possibilities have an emotional effect.
I think it's the simple things. So one of the nice things about this launch is that, people will talk about the ship, and the ship will go and do its research things, and everyone makes a fuss about the ship. And the fact that on the other side were standing the people who built it, like they had stood in a shed, like when there was nothing in the shed apart from just bare concrete, and you lay the keel, and every single bit of that ship was welded by a human being. And the humans made it bigger and bigger and bigger and bigger. And, when I was there, filming it being, I was the only person allowed to film on it while it was being built. And you can see they're welding things in that will never be seen again, basically, because they're then covered up by all this other engineering. And so part of it was the scale of it, and part of it was knowing what was inside it, knowing what it represented, that it was this kind of shell with the work of so many people. And yeah, and I think, and it was the quiet. There's something think the other thing often we don't do with big engineering is we're so busy shouting and like playing anthems and sort of making a lot of noise that we don't often just be quiet. And there's a very different way of looking at something when you're silent. And I think that is something engineering is always doing something, right? And actually sometimes the times it's most impressive when it's not doing anything.
See, that reminded me of Jodrell Bank, and again the silence of something enormous that, as the Lovell telescope, as it moves, it's so quiet and it's so huge. And it's quite, I remember looking away, and I was chatting with someone about a comment what we were making a program on, and then turning around and seeing that it had moved, and it just felt sneaky engineering. Nicole, we're talking of magnificent. I think something like the space shuttle is, that is, and in fact, most launches, I think when we see going to space, there is something which really connects with people. And you were the last ISS astronaut, weren't you, who came back on the space shuttle?
Yes, I was. And I don't know, as Helen was talking, all I could think about was that feeling, both watching launch, but also being in the crew module of the shuttle for a launch, where I don't know, you have this over 100-foot tall vehicle at the launch pad. It's made up of the solid rocket boosters and that orange tank and the space shuttle itself. And to me, it just looks like a work of art, just beautifully, standing there at the launch pad. And it's only held to that launch pad by 8 bolts. There's like 4 bolts around the base of each of those big white solid rocket boosters, right? And I don't know, there's something about that stillness, like you described too, that just, and the imagination, I think, of the power that's there. And then, the engines light and the whole thing twangs, as that NASA, technical term, the thing rotates and then comes back to vertical. And then you wonder where that stillness went, right? It just goes from this ginormous, beautiful compilation of engineering that was just standing there still to, going someplace super fast. And yet, as you watch it lift off the launch pad, it was like it was in slow motion, like this, this 7 million pounds of thrust lifting it off the launch pad. It's like it was just kind of lumbering, to get out of gravity and into space. And yet it does that in 8.5 minutes from the time those engines light to, you are orbiting in space at 17,500 miles an hour. And as Helen was telling the story of the ship, that was what was going through my mind too, was this stillness that transforms itself into this, almost unimaginable power and beauty that, that then in both from the ship and that shuttle, something good is going to come from it too, is what I really love.
Do you remember the first, because obviously you were an engineer at NASA for a long time before you then trained to become an astronaut. Do you remember the first launch that you saw?
I do. I actually was just out of high school, and I remember STS-1. My uncle worked over at the Kennedy Space Center at that time frame, and so our whole family went over to watch it. We were on the top of some apartment building across the river watching it, and yeah, I don't think it ever disappoints. You feel that same, and the closer you can get, of course, there's the rumble. Helen, I'm sure there was like the vibration and sound that went along with that as well, but just how your body feels it, but even more than that, just kind of the emotion of it, which is why I think Helen is probably shedding the tear when she sees this again too, right? Is that there is emotional power in it as well.
There's a wonderful thing about, maybe perhaps you know this. So I was once filming with alligators just outside Kennedy Space Center. So there's a swamp there with alligators, and the way the alligators, there's a mating call that the males do, and it's got two parts. It's got a bit where they vibrate their back, which is in the range that we can hear, and then they do this underwater thing, which is infrasound, which we can't hear. But when the males, it's a mating call. But when the males hear each other doing this infrasound, they start to copy each other. And they all start making the mating call. But when there's a launch, all the male alligators feel the vibration and start making their mating calls, which is I just love that. The idea, like exactly that infrasound that you were talking about, that has,
maybe that's why there's so many alligators around the Kennedy Space Center.
I've never seen anything launched at the Kennedy Space Center. All I've seen at the Kennedy Space Center is Duran. I saw them on the anniversary of Apollo 11, and I sat on Cocoa Beach at exactly the time that the launch would have happened, and it was had quite a kind of interesting psychogeographical effect. And then later on I realized, because I'd only just arrived, because I was I'd got the timing totally wrong. So as I watched this kind of ghost, and I timed it so perfectly, I could see it so vividly, and then the whole thing had even been a sham in my imagination. You've got a show and tell, haven't you, for us, Nicole? It wouldn't surprise me if it's behind you.
It is. I didn't want it to be so obvious, but it is quite obvious. So I think you can see it. Full art spacesuit. This one is named Exploration. And I know it's hard to see the detail, but each of those little patches is an original painting by a child in either a hospital or a refugee center around the world. We've got kids from over 50 countries involved with this suit, and our spacesuit company, I will say the spacesuit company, ILC Dover, who designed and built the suits that walked on the moon, the suits that are being used on the International Space Station right now, and they have two really amazing suits for future space exploration as well. They have, since the very beginning, volunteered and quilted together these art spacesuits. A couple of them have flown to and from the space station, and we've been able to do video conferences with the kids, and some in mission control centers around the world, as well as piping it into the hospitals and centers. And we are now building a suit called Beyond, which we are hopeful. I'm knocking on wood, holding my hands like this, crossing all appendages, because we're really, really hopeful to get at least one piece of art from a child in every country on the planet. And then that suit will, and we'll cross our fingers for this because we can never promise. We're hopeful we'll make it to space one day. But it will make its first stop at the UN Climate Change Conference, COP26 in Glasgow in November. So very excited about that. Uniting a planetary community of children through the awe and wonder of space exploration and the healing power of art. That's our tagline.
That's brilliant. Are they fully functional, or are they just pieces of artwork?
Well, I think that you can wear it, but it's more like the cover of the spacesuit. So you wouldn't want to put this on to head out the airlock and go outside. Though I'll tell you, every astronaut that sees these suits now, and I would say every astronaut, every cosmonaut, taikonaut, all of, every variety you can imagine, when they see these suits, they kind of wonder, like, why do we just have to wear those white ones? Why can't we have, something like this?
Well, it's like scuba diving, isn't it? I think, like all wetsuits are black, and I've got one that's got purple panels on it, and that is the only color I've ever seen. And it's like, why? Why do they all have to be black?
I know. Well, let's go into business together, because I've got some ideas about how we could incorporate some really cool Earth patterns into some.
Totally in for that.
Watching this, you can. There's on YouTube. There's various clips of. Now I can't remember which one it was, Nicole, where you're with a bunch of kids in a mission control and they see the space. Actually, it's. But just look up Nicole, and you will find that quite early on. There's some really lovely stuff there.
Yeah.
It's space for art, isn't it? And I always want to call it art for space.
I know, and it's we thought about that, but we were very deliberate about the Space for Art name. And it's the Space for Art Foundation. And I don't know, I feel like, how we discover our missions along the way. I really feel like this is my mission in life. I got to go fly in space, do some of those other things so that I could come back to Earth and work with these kids on these projects.
Brilliant. We've got loads of questions. So I should also say, if you want to know more about that on the Tips for Existence episode as well, we talked a lot about some of the interactions with the kids and their creativity, and also incredibly deep understanding as well from very young children about what space exploration is and what it means for us. Right now, we have got one question, which is, what was the before the universe began? But I'm going to save that for later, Nicole. If you're lucky, you won't have to deal with that. Helen, you get ready for that one instead. This is from the first one we have is from someone called Gunstick, who says, do you think that for long duration stays, for instance, the trip to Mars, artificial gravity via rotation is useful or a
Is that for me?
Yes.
I would put must on that one. I think we know enough about the way our bodies behave and respond to the microgravity environment and the level of countermeasures that we have to put in place, for short stays, even on the space station, that for us to be healthy and thrive when we get to Mars, I think that artificial gravity is going to be a necessity.
It's great though, isn't it? Because it sort of produces this mental image of a frisbee being thrown between the planets.
Yeah.
Sort of spinning disc that just
does.
Because the solar system is playing ultimate frisbee.
Yeah, I think I'd take the rotating spaceship over modifying my DNA and playing around with that first. Let's go rotate some ships.
The Seppo would like to know, have you observed light flashes in your eye due to cosmic rays? If so, how often, and do you get used to it?
I did, but apparently not as frequently as a lot of my colleagues did. I think everybody does to some degree, but I don't remember it being this like, oh my gosh, every night I'm having this wild flashing thing going on when I'm sleeping. But kind of occasionally. And I think you do get used to it. But I didn't have it as much as a lot of my friends did.
Next question. Marco would like to know, what is the main role of a flight engineer? But I imagine there's many more than one. But what is...
Well, it's funny. We have on board the space station right now, we have two roles, commander and flight engineer. So if you're not the commander, you're a flight engineer. And even the commander, I think, really is working like a flight engineer. And it just basically means jack of all trades. I mean, that's one of the really cool, I think, funnest things about flying as an astronaut now, is that you get to do a little bit of everything. We're all trained in one way or another to do pretty much everything on the station. And then we balance out how we distribute those tasks to everyone. But so in any day, it was a little bit different mix of things, but I'd be doing some science. There might be a spacewalk going on, flying the robotic arm. There definitely was maintenance activities and outreach, like, speaking to folks on the ground about what we were doing, but pretty much all of it at this point.
Well, of course, yours was the first tweet up as well, wasn't it, from space, I think, as well?
We did. There had been a tweet before, but we had the first tweet up, which was essentially a communication link between a bunch of Twitter folks on the ground and kind of this exchange, a little bit like we're doing right here, but there was Twitter action going on in the middle of it too.
I'm kind of interested in the job thing, because I wonder if there's you have been part of this almost the magical age where you got to do everything. Because I know it struck me when the SpaceX, the Dragon launch, when they took humans to the ISS, and I have much respect for the engineers that made this possible, but their cockpit looked so boring. It was this sort of plain white, sort of designed by an interior designer with a few iPads. And I know as systems get better, there are fewer things that you need manual checks on, but it also feels that in the future that there probably will be more specialized jobs, but also the machines will take over more of the heavy lifting. And maybe you've been part of this period where you were like one of the few that really did get to feel you knew how this thing worked, and perhaps that won't be as true in the future. Am I being overly pessimistic or optimistic there?
I don't know which istic you're being. It's like, I think that there's definitely this transition happening. I think if you looked at the cockpit of an Apollo capsule versus the shuttle, you'd see differences too, especially in the later space shuttle vehicles where you had the glass cockpit kind of thing going on in the front. There were the screens and things. There was certainly an evolution there. And yeah, there's this it seems almost overly simplistic presentation of everything inside of the Dragon capsule, right? Everything is electronic on these displays. But I think it's purpose-built as well. There's interfaces through all of that to the system stuff that you might need to interact with. But it's also purposely done in a way to minimize that interaction that the crew has to take for something, trying to automate as much as possible, which I think is, to the dismay of the pilots in our midst, because, they want their hands on it, flying it, and interacting just really, in the midst of it. But I think we're going to need that as we fly more and more people, as we get into, I don't know, I hesitate to ever use the word routine when it comes to leaving the planet and going to space and doing things. But when we get to be more regularly doing these kinds of things, but there is some beauty to, you go into a space shuttle cockpit and you sit there and you look up and there's like all these switches and circuit breakers and lights and things, and the fact that you can just even wrap your brain around what all that stuff is speaks again to the beauty of the way the engineering is laid out, and that it makes sense about how it's all sectioned. There's little drawings, like schematics overlaying the way the switches and stuff are, that if you forget something, you could say, okay, this line connects here, and that's when I would put this switch. But all that is somehow now in electronic form.
Well, I wonder whether there'll be an analogy in the future. I've got friends who are commercial airline pilots, and they all fly Cessnas on the weekend for fun. Mm-hmm. Because they say it's the only time they actually feel like they're flying.
Right. Right.
So, yeah.
Yeah, I agree. It's interesting that kind of that human interface to it, how it'll change, mode of transportation versus being part of the transporting, and it all, and enjoying it. And it makes me hope that we don't ever, this will seem a little bit of a stretch, but we have these beautiful windows on the station, and on, the shuttle had really great windows. The Dragon capsule has these great windows. I hope we never get to the point where we're so separated from this fact that we're flying in space that we pull the shades down to watch the movie kind of thing, when what you have outside is so spectacular.
So I love that image that Helen's kind of given there of just that, in the old days, Saturn V had a proper gear stick, 5 gears reversed, and then they made it automatic, and everyone was like, it's got boring, hasn't it? Paige, who is 7. Hello, Paige. Thanks for joining us. Paige would like to know, what are some of the things you can eat in space, and do you get dessert like ice cream? Because I presume granola's a no generally, isn't it, in space?
Yeah, anything that's kind of tiny and floaty, because you can't contain. We don't normally get to have, like, we don't have bread on space station or on shuttle. We didn't have it on shuttle because it's so crumbly that, if you imagine all that kind of stuff getting into the air and getting in your eyes, or you breathe it in, or it gets into the system stuff, that's not good. So we would use tortillas for anything like the bread substitute. But it's fun because you can pretty much eat anything. It's just not necessarily in the form that you would eat it down here. So a lot like camping food, packaged camping food, dehydrated. We've sucked all the water out of it for a couple of reasons. I think because it stays on the shelf longer, but water's heavy. So to transport that to space, you want to make things as light as possible. But Paige, it's a great question because on the space station, we have our international partnership, and that means we get food from all different countries on board the station. And my favorite dinner was the Japanese curries, and I loved the Europeans sent this really delicious mushroom pate, which was just basically ground up mushrooms with vanilla and hazelnuts in it. It was so good. And then, of course, we get things like M&Ms that we can't call M&Ms. We have to call it candy-coated chocolates because you can't say the word M&M because then you're advertising for M&Ms. But the other great thing is they pretty much plan dessert for every meal, even breakfast.
Wow.
Is there anything you miss?
Breakfast dessert. Tell me about breakfast dessert. I want to know about that.
Well, it's pretty much the same desserts you'd get otherwise, but it's like thrown into the, like allocated as part of the breakfast, mix of foods. They're really concerned about you not losing weight up there, about you maintaining muscle mass and, your bone density and that you don't lose weight. So there seems to be, in my mind, a kind of exaggerated requirement for calories, which if I had eaten as many calories as they suggested I do up there, I would have come home and like much rounder than I went. But
that's brilliant.
Those little brownie things seem to be in everything.
That thing where you feel like there is definitely some families where, we all know you go to that that part of your family and all they want to do is feed you. And you'd think that space would be the furthest away you could get from someone continually wanting to feed you. Nope.
No, they want to feed us. They want to feed us.
That's a terrifying. I'm afraid Nicole can't come back now because we can't get her through into the. People end up being trapped and becoming a circus sideshow. Yeah. Alex, who's age 7, says, "What do you do to relax in space? Do you have things like Netflix or TV?"
Yeah, well, the number one thing that you will find astronauts doing when they're relaxing in space is they will be floating in front of a window somewhere, just earth gazing, taking pictures, appreciating that view out the window. I don't know if they have Netflix up there yet, but they definitely, even in the old days, 10 years ago when I was there, they would send up TV shows and movies and stuff for you to watch. So we had that. Everybody had a playlist, music playlist that that you'd hear music going on throughout the station all the time. And then there's been musical instruments up there since the very beginning. On the station, there's a keyboard and a couple of guitars, and I think Katie left a flute. And a crew recently did a little jam session, and they had all those instruments out, but then one of the crew members had an empty solid waste container that they were using as a bongo drum, I think. And so that kind of thing. My friend Karen sewed and quilted while she was in space. I did a little watercolor painting while I was there, but I think this, the longer we live there, there's more of this kind of the humanity of us there as well, the human in space flight. And I think that's just going to continue. The farther we, travel from the planet, we're going to have to really be very, I think, conscientious about taking that human side of us with us.
I love that upturned bongo drum idea. The beatniks have taken over the ISS. I can't believe it. Lauren, this actually carries on from what we were just saying. This is from Lauren, who listened to Tips for Existence and says that on that you talked about how hard it was painting with watercolors in space. You were the first person to paint in space because the water droplets keep floating away. I found myself wondering how, when you're actually painting, it doesn't just run off the page or canvas as well. Also, was there a specific reason that you chose watercolors?
Wow. Well, I chose watercolors because it seemed like it would be the least toxic thing. Everything that you take with you has to be evaluated to make sure that it won't pollute the air inside the station, that that it won't hurt the crew members. And so these, like, really just like a kit of children's watercolors is what I took with me. You probably could have eaten it, if you wanted it and been okay. The water was fun. Painting with the balls of water was really fun. And, the balls of water would float around, and then you'd kind of carry them on the end of the brush, floating on the end, and have the colored ball of water on the end of the brush. But what it would do on the paper was, that I discovered very quickly, was if you actually touched the tip of the paintbrush to the paper, it's like it sucked all of the colored ball of water into it at one time. So unless you were wanting to do like blobs, which could be really cool, I guess, this kind of blobbed version of a watercolor painting, the way you really painted was by dragging the ball of water along the paper, not touching the brush to the paper. So that was a little bit of a lesson to have to learn in the floaty world of watercolor painting.
It sounds like you need a lot of coordination, because you have limited things to lean on and rest against. You can't rely on gravity keeping everything in the right place. There's lots of moving parts to all of that.
Yeah, you have to. It's like, I think I told Robin this before, where I wish I would have videotaped the whole process, because I think just in that kind of way you painted with watercolors, you could really describe what it's just like to live in microgravity. That everything floats. So you've got to get yourself in a place where you've got your feet under the little rails to hold yourself in position. You need everything all kind of organized around you and, in arm's length. Figuring out how to hold the paper and the picture that you're using as your reference in your paintbrush at one time to do it. It was a little bit, mentally different in that you physically had to set up in a totally different way than you would here on Earth. But like everything, it was just kind of part of the adventure. You don't want it to be exactly the same as what you would do here on Earth. You want to experience it a little bit differently. And that's the way everything was up there.
Brilliant. Thank you very much, by the way, for all your questions. We have loads of questions coming in. As I mentioned before, you can either pop them in the live chat or just tweet us at Cosmic Shambles. And mention again that Tips for Existence episode is up at cosmicshambles.com as well. If you can support us via Patreon, please do. That's how we keep making all of these things. Now, the next one, this is from Jill, would like to know about time shifts on the ISS, whether you do basically clock out at 5 p.m, it's kind of all done and dusted, or how the tasks are worked out.
Well, first of all, I'll just say we are on a 24-hour clock, but we set our time to GMT. So we work to GMT. That seemed to be a good balance between, for all of the different international partner countries to work together, throughout the day. And the ground, our mission control folks, man, they plan the day out. It's like in 5-minute increments, from the time you get up in the morning till the time you go to bed at night. There is 8 hours allocated for sleep, and they have meal time set throughout the day. So that's really good. But in between all of that, it's, that mix of what we talked about before of science activities and maintenance and major tasks like spacewalks or flying the robotic arm or crews arriving and departing, that kind of thing. And it's a very, very busy schedule up there. And so you're really kind of happy when the end of the day comes and, you're turning all the cameras off and you're floating around the dinner table with your crewmates. And then everybody finds their way to a window, to a phone, a computer to call home and talk to family, and which is nice. We have that opportunity. The communication setup is really good to be able to talk to friends and family at home, and then just kind of, experience it, to be living there, not just working there too.
And how much do you ever feel time for rebellion? Because I know when I've been in environment, so I've worked on ships a lot, which is not the same, but it's got some elements, some of the elements, right? And everything is very regimented. And I find that after, it depends how much I like what's going on actually, but perhaps after a month, there's a kind of cutoff at a month where I stop being like, I really suddenly start to notice the routine. I'm like, I just want to do something else. I just want to be a rebel for 5 minutes. Are there any opportunities for being a rebel just a little bit, or do you have to exactly follow the schedule? I mean, considering that NASA has spent a lot of money training you to put you up there to do it, are there ever little hints of rebellion in there?
Oh, absolutely. And I think NASA gets that too. I think all the space agencies now, as they've worked with us more, get that. And so the schedule, that while it's planned out in these like 5-minute increments, they've come to the realization that the crew actually can figure out how to lay this stuff out themselves, how to clump those jobs together in even a more efficient way, and end up with more free time, or get things done even better. And so there's a little bit more flexibility in that now, even though they will still continue, I think, to schedule it that way. I think the kind of the rebellion stuff that I saw was in the way we would move through the station. And I think it was just taking advantage of this really cool environment that we were in. It was like, yeah, I need to get from the lab module down to the service module to do this job. But you know what? I'm going to roll and flip and fly to get there, and I'm going to stop at that window and take a few pictures before I, get to this next task. I'm going to have a little conversation with my crewmates on the way, stuff like that doesn't seem, aggressively rebellious, but there was just something liberating about it to be able to behave that way in this really unique environment. Yeah.
Now, here's a nice specific one. Mike would like to know, what's that cool-looking science fiction figurine that you've got behind you? I think on what would be your left shoulder.
This way?
Yeah. There's one right behind you, and Mike is fascinated to know what that is.
Is it
I think the lower one, by the kind of picture that looks.
By the painting.
Yeah, just by the
painting. Oh, here, hang on. Let me see if I can do this. So, does it look like a sculpture almost?
Yeah, kind of. Yeah.
Yeah.
I think that's what Mike means.
So there's some rocket ships up in the, like retro-y looking kind of sci-fi rocket ships up in the bookcase. And then if I come down, I wish I'm not going to be able to move my arm the right way, this way, and just above it, there's there's a sculpture here. I'm going to see if I can move and if this will work at all. Just unplug the thing, but a little bit closer. Let's see. This guy here?
Yes.
Yeah, I reckon that's the one Mike means.
Yeah. So it's a bronze sculpture by an artist, Jean-Louis Gonzalez, who lives in Miami, and it's really cool. It's like the spacesuit floating, and it's carrying a bouquet of flowers, and it's gorgeous. It
makes me think of Peter Pan. It's almost a Peter Pan.
It's very floaty looking. It's gorgeous. It's really I love it. Yeah, I'll send you a link to his.
Oh, brilliant! We'll put that up. So Mike, we'll put that up on our Twitter. This is Michaela would like to know, her daughter has. Now, this is an interesting question because it's about space exploration, but it's also a Helen specialist area as well. So I'm going to throw it to you first, Helen, because Michaela's daughter would like to know about bubbles. She would like to know that if she took a bubble machine onto Mars or Jupiter, could bubbles actually form?
So I assume she's talking about soap bubbles here, where you blow some air through a soap film, and there's nothing to stop them forming, but they might not last very long. So the thing that really, there's two things that will break a soap bubble up. One of them is water evaporating, because if you lose all the water, but you've got a soap layer on the outside, a soap layer on the inside, and a thin layer of water between the two. If the outer and inner soap touches, then you have a hole and the whole thing will burst. So if the water evaporates, your bubble evaporates and your bubble won't last very long. The other thing is that the other reason soap bubbles pop is that gravity drains all the water down to the bottom, and so it thins at the top, and again the outside and the inside are more likely to touch each other. So on planets with lower gravity you have less of the second problem, but more of the first. Well, if they have less atmosphere you have more of the first problem, because water will evaporate away more quickly. Also depends a bit on the temperature, because obviously if water freezes, well, I suppose you've got an ice bubble that might last a bit longer. So it's a balance of different things. But in principle, as long as there's some atmosphere, there's no reason why you couldn't have a bubble. If there was no atmosphere, then the problem is the gas would just keep expanding, would push the water out. So you wouldn't, it would get thin, it would get too thin too quickly. It'd be a really interesting thing to do though, to take different bubble mixtures. You know, perhaps when they're into citizen science things, doing citizen science experiments on other places, we can suggest that as let's try all the bubble solutions and see which one makes the best bubbles on Mars.
Yeah, what's the first experiment we're going to do on Mars? Well, Helen Czerski's been in charge of this particular one, and we're just doing the bubbles.
No
we're doing the
bubbles.
bubbles.
Yeah. I think we should. Wouldn't it be cool if, in addition to that little helicopter that's going to fly next month, if there was a bubble machine on Perseverance to see? I think that would be awesome.
I would love that image. If this little drone that can fly, if it can just take pictures of the rover blowing bubbles, like I'm just this is my moment of rebellion. I'm just going to sit on Mars and blow bubbles at you. It'd be great.
Why did the experiment go wrong? Someone decided to put a bubble machine on it, and apparently that made the whole thing a lot more difficult. Helen Czerski.
Well, it's so got into places it wasn't supposed to get.
Andy would like to know, do you notice when you're on the ISS seasonal changes as you look down on the Earth? And also, what is your experience of day to night over the 90 minutes as you go around the Earth?
Yeah, that's really fun. You know, we look out the window at the Earth all the time, so we're noticing all kinds of changes, and it's almost like the seasons are changing all the time while you're looking down there, because you can see so much of the planet. So that's really cool. The night-day thing, we're going around the planet every 90 minutes, right? So about every 45 minutes, you get this sunrise or sunset. That happens, 16 times a day. And that never, I mean, there's everything about it never gets old, but that stands out to me as one of those things that's just this totally stunning reminder of where you are in space like that, to watch this Terminator line, either, the dark turning to light or the light turning to dark on, as it moves around the Earth, and that yes, I guess day-night cycle that's happening on the planet. And yet for us, we're experiencing it 16 times. You cannot use the view out the window as your, indicator of, is it time for me to go to bed or not, kind of thing. That's, more the body clock, as happens in a lot of places where, the light stays longer or the dark stays longer. But it's one of the most, when I think about flying in space, that day to night kind of thing, sunrise, sunset, is what stands out, absolutely the most to me as a reminder of what it was like to be there.
Does that mess up your circadian rhythms? I mean, do you sort of have problems going to sleep at the right time and all that kind of thing?
No, not really, because the windows aren't big enough to be wow, blasting light in and then dark for 45 minutes, every 45 minutes. We're really in control of what the light is like for us. And I think that happens a lot, when you're submarines, for sure, when you're locked in a ship, if the weather's bad or something, you just got to kind of control that yourself. When you first get there, I think between the excitement, the adrenaline, and that you're now on GMT, if you weren't on that before, there's a little bit of a shift, of a kind of jet laggy feeling, but you get over that pretty quickly. And on station now, they even have the lighting systems where, a couple hours before bedtime, they start shifting it to more of a red light. In the morning, it's the blue light comes on to help you wake up, and then the white light during the day. And so they're trying to incorporate things like that to help with that too, if people do have issues. But it's not because of the light coming in and out of the windows. They're not big enough yet. We need those big, I can't remember what that movie was, where it's just like this wall of windows, with your ship.
One day.
Lots of them, yeah.
Jane's got a similar question, I think, about adapting in some ways, which is she says she's heard a lot of astronauts saying that they adapted quite quickly to being in such a different gravitational atmosphere, but they found it much harder when they returned to Earth, that took a lot longer to returning to that sense of normality. How did you find it?
For me, it was pretty much, it was kind of equal on both sides. What I think is interesting about that is that they still haven't determined, they haven't been able to like look at a person, their shape, the experiences they've had, how their body responds here on Earth to, going out on a boat in really bad weather or flying in an airplane and doing provocative things, how you respond here on Earth. They haven't figured how that equates yet to going to or coming back from space, which I think is a really interesting thing, that we don't know. That tall skinny person is going to, respond better to get into microgravity or coming home to gravity. I was really fortunate. I felt great when I got to space. Could not wait to eat my peanut butter jelly sandwich that they packed for me in my little travel kit, and felt pretty good when I got home. When I got home, it was more feeling really, really heavy. I think that's common to everyone. And then pitch, like if I moved my head up and down, the whole world was spinning for about a day. And I wish I could have gotten sick. That kind of, if you got sick, you'd feel better feeling, but I couldn't get sick. But it's pretty incredible how, regardless, even if it takes somebody a little bit longer on one end or the other, once they've adapted, they've adapted. And I think everyone I've spoken to is, at least with the getting to space part of it, when they go back, it's like your brain just like switches, reprograms itself to, oops, I remember what it was like to be here and I'm going to feel good. And that's a really good thing, especially if you didn't feel good when you got there the first time and then you're kind of dreading, am I not going to feel good again? And to know that you can get there and feel good. Yeah.
What's it like though when you wake up? So you've spent 4 months, over 4 months, wasn't it, on the ISS, and that I even think just touring normally like I do, which is a very terrestrial form of touring. It's very unadventurous. It's really weird when you actually find yourself back for a period of time in one place, which is your home. Let alone the idea that you've been in space and you've been looking back down at the planet which you are now lying on. How long does it take to kind of just wake up and go, oh, yeah, no, I'm home. It's fine. Yeah, this is normal.
It is very weird. I mean, I remember sitting on the runway and thinking, especially after the first flight, it was like, wow, an hour ago, I was in space floating, and now I'm back here on Earth. And I think it actually happened pretty quickly. And I say that because I was fortunate to get some advice from people who had flown before, and I remember getting off of the shuttle the first time on the crew vehicle that takes us back to crew quarters, and Peggy Whitson was there. She was the chief of the astronaut office at the time, and she was on board waiting for us. And we just had this conversation, about welcome back and hugs and all that kind of thing. But she was like, all right, Nicole, you're going to get back to crew quarters. And they're going to do all these tests on you. It's going to take a few hours. All you're going to want to do is go to bed. And she said, don't do it. She's like, I highly recommend that instead, just go, take your husband and your son, grab, Bruce, your physical trainer, and just go to the gym and get on the treadmill and just walk for 20 minutes. Walk slow for 20 minutes. Just do it. And she goes, you will be amazed at how quickly the little hairs in your ears and your brain and body just start to recalibrate to gravity. Whereas if you just go back and go to bed and go to sleep, you're just putting it off for another day, a day or so, and it's going to be more difficult to do. And I did that. All I wanted to do was go to bed, but I went and I got on that treadmill, and I swear after 20 minutes, I got off that thing and I was walking straighter. I wasn't like just falling around the corners, walking. I was turning around. It was incredible how quickly that happened. So I am very thankful to Peg for that. Those words of wisdom.
Gary would like to know, so I'm going to rattle through now because we might get through all the questions, we might not. Would like to know, having flown both on Soyuz and on the shuttle, compare and contrast. What was the difference in your experience?
Well, I trained to fly on both. I ended up only flying shuttle. I say only, I'm very happy for that experience. And just based on my friend's experience, there's kind of a difference, like that you switch it. Launch on a shuttle, really, really dynamic experience. On Soyuz, they like look at the clock and the altimeter to say they've lifted off. It's in line, liquid fuel. I mean, they know they have, but it's a very different experience just on the launch side of things. Landing, shuttle is like this sweeping, swooshing, graceful, and then a little chirp on the runway, whereas landing in a Soyuz, and I'd imagine in the Dragon capsule or any of these capsules that we're going to have now that are either hitting the water or hitting land that way, is a much more dynamic experience.
That is possibly the best euphemistic phrase I have ever heard for hitting Earth with a bump. It's a more dynamic experience.
Like a car crash. Yeah.
Daniello says, was wondering if you notice visible changes, or indeed that whether it's easier, not necessarily you in your individual, but over time, in terms of things such as pollution and sea level changes, how much that can be observed from the ISS.
Yeah, I'm not so sure about like sea level changes. I think there might be ways to look at coastlines and see that through like the view out the window or the imagery that we take. Everybody is really, really interested in and trying to document changes that you are seeing, though. There's like, fires are very visible, big wet weather patterns are very visible. Deforestation, just this stark contrast between a place that just looks like it wasn't supposed to be that way to this beautiful forest, next to it. Smog, dust kinds of things where you can actually see these sandstorm, dust storms happening, in Africa that are, you see it like across the ocean and, landing in another continent, that's pretty incredible to see. Everybody that I know of wants to photograph the changes they're seeing down like Patagonia, glacial kind of activity. And I think, besides just our own personal interest in it, that photo documentation has become very useful, in addition to like the satellite imagery that we get and stuff, to helping scientists track the changes on the planet. So we feel like we're part of that. We actually feel like citizen scientists when we're doing, the photography, just our own Earth observation on station, because we think it can add value.
Well, it's really interesting because the satellites are doing an amazing job. But the thing about the satellite data is there's too much for any human to look at. So it's all kind of being stored away. But unless someone goes back and goes, OK, so what was the pollution? What could we see in satellite data on these dates? There's physically too much to incorporate into any known computer model. And so it's actually, in some ways, watching it is really valuable because you're noticing patterns. Whereas there's so much satellite data on all of these things now that a scientist on the ground, it's a lot harder for them to notice patterns because there's just so much data to process. But if you're up there, I guess you can go, oh, I wonder what that is.
Yeah. And Ray, I mean, we've even had the opportunity to see like volcanic activity in places that nobody knew it was happening at the time. And, just send down a picture or comment, to mission control. And they're like, oh, my gosh. So they alert or let somebody know, it might be in an unpopulated area or something, but just is something that they would want to know about. And I love that now there's become such a focus. There's really a focus here on Earth, taking this satellite data and doing the analytics with it, really figuring out how do we process that so we can see these trends or changes and provide feedback to people that can take action with it.
And the last few questions we've got. Virtual Stephen says, on the Cosmic Shambles Atlantis series, Chris Hadfield talked about how he saw the shuttle as a large series of engineering compromises to make it a viable ship. And Virtual Stephen was interested in what you thought in terms of that idea.
Yeah, I think that's an interesting way to think about it. And then I think you have to look at it like, wow, how many major projects like that where you really are compromising, where you're trying to do, satisfy the requirements of everyone. How many times does that work out as well as it did with the space shuttle? I mean, you look at the history of the space shuttle and the kind of work in space that was accomplished with it. Crew, cargo, deployments, building space stations, the science that happened there just within the shuttle itself. That doesn't happen often. to where in every one of those areas it was successful. And so I'm very thankful for that compromise in the end, and how wonderfully it worked out. I would love to still see the shuttle flying.
The Christoph would like to know, will the ISS eventually be out of date, or can you just keep upgrading it?
I think they could keep upgrading it. I think what they're going to try to do is evolve in some ways so that maybe pieces of it can be, continue to be utilized. Perhaps we could boost parts of it up and build off of it. I know companies like Axiom Space are looking at options with that. How do you utilize the structure and systems that are already in place? My guess is there will be some part of it that just sadly they're going to have to deorbit at some point. I think right now we're looking at 2028 as the earliest for that, which doesn't seem that far off. But when you think about it, man, we're, a little over 20 years now into this operation of the space station. And, that's longer than I think was originally planned. So it's amazing how we can extend the life. Just like when you look at the rovers on Mars that were supposed to have like a 3 to 5 year life, and they're just still going. Pretty cool.
But it's unimaginable even now, the idea that it wouldn't be there, or there wouldn't be something doing that job. I mean, we've taken it for granted so much in those 20 years. The idea of it not being there, of not having this human permanent presence in low Earth orbit it's a bit disturbing.
Well, I think that's why it will be extended in some way. There will be other stations that will come even commercially, sending ourselves back to the moon for permanent presence there is pretty exciting to me as well. I like, again, I'm crossing all appendages and knocking on the wood and doing, all the stuff that you would do to just really hope that we recognize this value of that permanent presence. And my husband calls, the ISS is International Space Station. He says that sadly, sometimes it's probably more thought of as the invisible space station. It's just this place, this masterpiece in space that for these 20 years has been operating with representatives from 15 different countries peacefully, successfully, kind of quietly up there doing its thing, everything about it off the Earth, for the Earth. And if we can make that more visible, I mean, that's why I love doing stuff like this. We talk about it. More people are going to know about it. They're going to get that Spot the Station app on their phone. They're going to go out and look at that dot of light moving across the sky, and they're going to know there are 6 or 7 people up there representing humanity and doing stuff that's good for all of us.
Do you know much about oils that are used in cooking at all? This is a terrestrial question. Because this is one of the questions we've got in. Mel wants to know, why can olive oil have a shelf life of 3 years and walnut oil only a few months? It's a long shot, this one, to be honest.
I don't know. I do know that I have olive oil on my shelf that has probably been there for a lot longer than its shelf life, and it always seems to be good, but I have no expertise there. I'm sorry. Right,
we'll be dealing, we promise you this, next week we'll deal with the walnut oil and olive oil conundrum.
I've got answers to that for next week, Robin.
I knew you probably would, and there's a bunch of questions we haven't asked. We will roll over to next week, just because we tried to deal with all the questions which were really specific for people who've been into space, because we don't have them on as often. So that's why we did. So there are quite a few other questions that we've got. David, we'll get your question. I am listening. We'll talk about what we know about the beginning of the universe next week. Final question from Scruffy Doo is, what is the time zone that you use on the ISS?
GMT.
Right.
Yep.
Brilliant. I thought that would be a quick one. That's why it's a good one to end on. Now, Nicole, you've got a book, haven't you, coming out later this year?
I do. It's out for pre-order now. It's called Back to Earth, and really not a memoir at all. It's kind of the story of how a lot of what we talked about today, how the way we live and work on this International Space Station, this mechanical life support system that we build to mimic what Earth does for us naturally, and how we should be acting more like crewmates down here on the planet.
Well, that was again, that was a fascinating part of that conversation we had a couple of weeks ago. So thank you very much, everyone, for all your questions. I'm sorry we didn't get through all of them today. I can't remember who we've got on next week, but I know that on Easter Sunday we have Brian Green with us. So I think Tony Ryan might be on next week, who's been a regular guest on Infinite Monkey Cage as well. And we'll keep up to date, look at Cosmic Shambles, and we'll tell you who else is going to be on. Of course, Helen will be with us next week. Reminder again, the current Tips for Existence is Francesca Stavrakopoulos, Lulu, who is a brilliant atheist Bible scholar. And we don't really deal with it enough, but we did deal with some idea of the possible death rituals of elephants, as well as a lot of other things in that conversation. And also a reminder, the latest Uncanny Hour is about Derek Jarman and Jubilee. In the previous one, we did one about John Carpenter's The Thing and some of his other movies as well. So do support us via Patreon if you can. By the way, I've had just, and I'm not saying this to show off, but I know some people have been worried. Yesterday, I had the they're not worried about me, I should add, the AstraZeneca vaccine. And I know I've seen some people saying, oh, how did you feel afterwards? I feel slightly groggy, but I don't think that's anything to do with that. I think it's because I'm a naturally groggy human being. I know 5 other people who had it yesterday, all of whom feel absolutely fine. So I just thought I would mention that. And again, congratulations for, if you were listening to the early conversations we had about COVID this time last year, no one would have imagined the speed to vaccination that has occurred, which I think is so. Enjoy the rest of your weekend. And hopefully, if we don't see you before, we'll see you next Sunday or live 10 a.m. on Tuesday morning. Bye-bye. Oh, are we off yet or aren't we off? What's going on? Has Trent pressed the wrong button?